Dear student, in the previous classes, I had discussed about the group 16, all the compounds and its properties has already been discussed. Now, we come on group 17, and this group 17 called the halogen family. And why it is called the halogens? Halo means salt, gen means producer. The members of this family produces the salt. As for example, very common is NaCl, NaBr, KCl, like that, NaIO3, KCl, that is MgCl2.6H2O. These are called the salts of this, that is formed by the members of this family. So these are called the salt producer, regarded as the halogens. Now, the source of this, these are very reactive element, and they are not found in the free state. They are found in the combined states. This fluoride. Fluoride is found in the form of that is fluorspar, CF2, fluorapatite, Ca3PO4 का whole 2, Ca, that is this is Ca3PO4 का whole 2, this is CaF2, this is called the fluorspar, like that. And the chlorine, rich source of chlorine is the seawater. In seawater it is found approximately 2.5% by volume, and the other in the dried sea or seabed, that is it is found in the form of their salt, NaCl, carnallite, etc. So these are the occurrence of these salts. Now this bromide is also found in earth crust. It is very little amount, 0.007%, but in the seawater it is found in the major amount, such as NaBr, KBr, like that. And the iodide is also found in the form of iodate in the salt bed, in the salt bed. So these are the occurrence of the members of this family and where it is found. And ultimately we say that the great source of this salt is the seawater. Seawater is the great source of this salt because it can be prepared. Even sodium chloride, the amount is prepared from the seawater. NaBr, that is also prepared from seawater, and also the sea lake and the seabed. So that is called the rich source of this salt is the, that is sea and the sea water, right? Now we look at the members of this family. So the members are fluorine, chlorine, bromine, iodine. So these were the occurrence. So we come on the halogens. Halogens, right? Halo means salt, gen means producer, salt producer, right? So we look at the members of this family: fluorine, chlorine, bromine, iodine, acetate. Again we know the atomic number. This is 9, 17, 35, 53, and this is 85. Then the electronic configuration: helium, neon, argon, krypton, xenon. And this is here chlorine, bromine, iodine, acetate. Now here is 2s2, 2p5. Here is 3s2, 3p5. Here is 3d10, 4s2, 4p5. Here is 4d10, 5s2, and 5p5. And here is 4f14, 5d10, 6s2 and 6p5. So this is all about the electronic configuration. So we must know the electronic configuration. This term is called the electronic configuration. Need not to write the whole configuration. This is the outermost orbit configuration, and this is called the atomic number, and these are the elements of this family number. So in valence cell, and in valence electron is sum of this 2s and 2p, and this is 3s, and this is valence electron is 7. So it is called group 17. So we are called it group 17 in the modern concept of periodic table. So this is all about the elements and about the electronic configuration. Now it's atomic and physical property. This is atomic and physical property. Physical properties. So first is atomic and ionic radii. This is atomic radii. Atomic. So the general trend, as we go in the period from left to right, the radii decreases. Left to right in period, the variation you know it, period. If left to right, the radii decreases. So this group 17 had the smallest radii in each period. If we come down in a group, so radii decreases in period, but we come down in a group, so the radii increases. Now another point, so our variation of radii, that is, it is just before the group 18, so it will have the smallest radii, because we have the concept that is the radii on moving a period decreases because nuclear charge increases and electrons are added in the same main energy level. That's why force of attraction increases, so its radii ultimately decreases. Now, if we come down the group, although the new energy levels are added, although nuclear charge increases, but the additions of the new energy level is more predominant over the nuclear charge. That's why its size increases. Similarly, if it is a size here, it will come here. If it is here, then it will like this. So this is the increasing order and this is the decreasing order. Now come on ionization enthalpy. Ionization enthalpy. So delta IH. So this is ionization enthalpy. So halogen have the high ionization enthalpy. High ionization energy. Why it will have? Because in its outermost orbit, one factor is due to small size, because ionization energy is related with that of size. If size decreases, then ionization energy increases. Now all halogens will have the high ionization energy because these halogen are smaller in size. Another factor, the innermost orbit, it will have the 7 electron. So it is very difficult to remove the electron from the outermost cell. So for it is easier to gain electron. That's why if we want to remove the 7 electron, needs very high energy. That's why its ionization energy is very high. So two factors, that is size due to small size and due to configuration, because needs very high energy to remove electron. Right? And the second cause, and the first is due to small size. So this is the second factor regarding the atomic, that is ionization energy. Now we come on the next point. At this point, the third is here, if I take it, that is electron gain enthalpy. This is electron gain enthalpy delta EGH. It is called electron gain enthalpy. Gain enthalpy. In the previous topic, in every group, this term has been discussed. So, electron gain enthalpy, suppose this is a gaseous atom, electron is added, then X minus, and here the energy is released. This is the definition of the energy. So, electron gain enthalpy is the amount of energy released when an electron is added to isolated gaseous item. So, all the electron of all halogens have tendency to gain electron because they have outermost electron in outermost orbit, that is 7 electron. So to attain the stable configuration, it has a sort of only 1 electron, so it will have maximum tendency to gain electron. So when electron gain, negative ion is formed. That's why halogens are called electronegative element, and the energy will be released. So what will happen? As our general trend, if we come down in the period, electron gain a group, in a group. Suppose if we come down in a group, then electron gain enthalpy, variation in group. Third point, variation in group. Variation in group. That is electron gain enthalpy. Variation in group. Variation in group. That is delta EZH, or electron affinity. It is also called electron affinity V. Right? What will happen if we come down in the group? That is electron gain enthalpy delta EZH decreases. Decreases means going to be less negative. Going to be less negative. Less negative. Less negative. Means if it is fluorine, bromine, and iodine. Right? So if we'll come down the group, this will have the less negative. That is less negative. So fluorine should have higher electron gain enthalpy, right? So the order of this is F, Cl, Br, this is I. This is the order of electron gain enthalpy. Order of electron gain enthalpy. Electron gain enthalpy in electron gain enthalpy. Why this order? Now here there is exception. Why fluorine has less negative electron gain enthalpy than chlorine? This fluorine here, why fluorine has less negative electron gain enthalpy than chlorine? That is chlorine. Why? ऐसा क्यों होता है? So this is creates a question, and this exceptional behavior is due to the small size of F atom and the electron present in a compact 2p subcell, so it will causes inter-electronic repulsion. So there are two factors due to small size and inter-electronic repulsion. Fluorine, exception of fluorine due to small size of fluorine and inter-electronic repulsion. Repulsion. Why? Because the electron are present in a compact 2p subcell. यानी फ्लोरीन का इलेक्ट्रॉन गेन एंथैल्पी ज़्यादा होना चाहिए, यानी मोर नेगेटिव होना चाहिए, लेकिन ये होता क्या है, बहुत कम क्लोरीन की तुलना में कम हो जाता है. तो कम होने का कारण क्या है? तो यहाँ एक्सेप्शन ऑर्डर ऐसा आया, ये डिक्रीजिंग ऑर्डर है, लेकिन हियर इज द एक्सेप्शन कि क्लोरीन का ज़्यादा हो गया फ्लोरीन से, देयर आफ्टर इट इज डिक्रीजेज मीन्स गोइंग टू बी लेस नेगेटिव. डिक्रीजेज का मीनिंग है लेस नेगेटिव. तो ऐसा कम होने का कारण क्या है कि फ्लोरीन का साइज छोटा है, इलेक्ट्रॉन क्या आता है, कॉम्पैक्ट टूपी सबसेल में है, टूपी है या डी नहीं है, इसके कारण क्या हो जाता है, इंटर इलेक्ट्रॉनिक रिपल्सन होगा, इसीलिए इसका इलेक्ट्रॉन की यानी एंथैल्पी क्या हो जाता है, कम हो जाता है। नाउ फोर्थ पॉइंट इज, नाउ फोर्थ पॉइंट, कम ऑन द फोर्थ पॉइंट। देखिए फोर्थ पॉइंट है इलेक्ट्रोनिगेटिविटी। इलेक्ट्रोनिगेटिविटी, अब इस पर क्या हम लोग जानेंगे, इसको बोलते हैं इलेक्ट्रोनिगेटिविटी। निगेटिविटी ये क्या होता है, हम लोग यदि ग्रुप में डाउनवर्ड्स द ग्रुप आएंगे, दैट इज फ्लोरीन, क्लोरीन, ब्रोमीन, आयोडीन, अस्टेटाइन, राइट, तो हम लोग का इलेक्ट्रॉन गेन एंथैल्पी डिक्रीज करेगा, डिक्रीजेस, and this is a fluorine is the most electronegative element in the following. Most electronegative element, EN stands for electronegative element in the periodic table. In the periodic table. And the second most electronegative element is oxygen. After fluorine, the another element is oxygen. So when we come down in the group, its electronegativity decreases. So electronegativity is expand. Now metallic character, this is very, so these are the common point. Metallic character, that is all are, that is these when we come down in the group, non-metallic character decreases, metallic character increases. So non-metallic character decreases and the metallic character increases. So these are the atomic properties. Now come on the physical properties. Physical properties, melting point and boiling point. And the fifth point is MP and BP. So this MP BP is decided on the basis of the key point depends upon the intermolecular force. That is depends upon bonds and intermolecular force. Intermolecular force. Here, force. So if we come down the group, the size of atom increases, magnitude of van der Waals force increases. That's why its melting point downward the group. Down the group increases. Down the group increases. Right? Why increases? Why increases? Because size of atom increases. Size is related with intermolecular force. Intermolecular force. Size increases, intermolecular force increases. That's why MPBP increases. This is the relation. So we are able to say the melting point and boiling point. Now, the sixth point is color. Sixth point is color. Color. Question asks, why halogens are colored? Why halogens are colored? Halogens colored होते हैं, क्यों होता है? So the simple reason कि here that is for the color is due to the excitations of electron, and for excitation, that is from ground state to higher state, it needs energy, right? As we come down the group, size of atom increases. So to excite the electron, that is energy decreases. Now the color of the halogen is due to the transmitted light. Color of halogen is due to the transmitted light. So all halogens are colored due to excitation of electron by absorption of light, and the color of halogen is due to transmitted transmitted light. So as the size of halogen increases, the energy, that is the of the radiation absorbed decreases. So the transmitted color, if it is decreases, the reverse the transmitted color will be more deeper and deeper. That's why sometimes it is said that that is fluorine. It is smaller in size, and its color will be, that is, it will show the yellow. Chlorine, yellow is green. Bromine, that is brown. So this color is due to the transmitted light. So simply ask the why halogens are colored. Due to the excitations of electron, the energy absorbed from the visible region, and the color is due to the transmitted light. So the halogen shows the certain color, right? Now after color, the bond dissociation enthalpy. 7 point is bond dissociation enthalpy. 7 point. Bond dissociation enthalpy. Or simply say it bond energy. Right? So simply bond energy, as the size of atom increases, that is bond energy decreases. So the order should be fluorine, this is chlorine, this is bromine, and this is iodine. Should be. Here you mentioned here that is should be. Right? This is order of bond energy, and this is called the decreasing order. Decreasing order. But the actual order is this is chlorine, then bromine, then fluorine, then iodine. Now here question, why fluorine has low bond dissociation enthalpy than chlorine and the bromine? So the question arises, so whenever the question is given, if the halogens are given fluorine, if the halogens are given, suppose halogens are given fluorine, chlorine, bromine and iodine, and it is said arrange in decreasing order, this order will be wrong, right? This is the correct order. This is correct order. This is a correct order. Right? Now the question, here exception is fluorine. Exception is fluorine. Right? Now why? Question, why fluorine has low bond dissociation energy than this is chlorine and bromine? Because as the size increases, bond energy decreases. So order should be like that, ये होना चाहिए, लेकिन ये ऑर्डर नहीं होता है. ऑर्डर कैसा होता है? करेक्ट ऑर्डर इसका ये है, जब भी आपको सजाने दें तो दिस इज द करेक्ट ऑर्डर. ये डिक्रीजिंग ऑर्डर है. ये कैसा ऑर्डर है? डिक्रीजिंग ऑर्डर. यहाँ लिख दे रहा हूँ, दिस इज शुड बी डिक्रीजिंग ऑर्डर है ये. दिस इज द डिक्रीजिंग ऑर्डर, राइट? तो अब ये इसमें फ्लोरीन यहाँ आ गया, जबकि इसको शुरू में रहना चाहिए. तो अब आपसे क्वेश्चन पूछ देगा कि फ्लोरीन का बॉन्ड डिसोसिएशन एनर्जी जैसे इलेक्ट्रॉन के एंथैल्पी में आता है, उसी तरह से ये कम क्यों होता है? सो दिस इज सिंपल रीजन. दिस फ्लोरीन इज स्मॉल इन साइज. ड्यू टू स्मॉल इन साइज, it will causes the inter-electronic repulsion. This is fluorine. So it will causes the inter-electronic repulsion. That's why it will have lesser amount of energy is required to break it. So its answer, that is concrete point is due to small size and inter-electronic repulsion. So this is the reason for the exceptional behavior of fluorine, because fluorine has a small size, so they will causes, the orbitals are very compact as are present in 2p, so they will causes interelectronic repulsion. So if there is a repulsion, already it is weak, so we have to supply less amount of energy. Here they are large in size and it is no repulsion. That's why chlorine will have the high bond dissociation enthalpy. So this is the reason. This question is very important and this is the exceptional behavior. So color of the that is halogens are colored due to the excitation of electron, and for excitation we supply the energy, and the color of halogen is due to the transmitted light. If it absorbs the, that is light of the shorter wavelength, then reflected light will be in longer wavelength, right? If it is light in color absorbed, then its transmitted color will be very deep in color. So the next point is oxidation state. So oxidation state. So देखिए, this is oxidation state. Simple. 8 point something, oxidation state. Oxidation state. If you will look at the configuration, fluorine always shows oxidation state -1. In some of the compound, fluorine shows oxidation state exception, that is +1. If you will take HOF, then oxidation state here, that is +1. But as a general trend, fluorine always shows oxidation state -1. If we not consider the exception, then fluorine is -1. Why? This is due to the most electronegative nature of fluorine. -1 due to most electronegative nature of fluorine. So while other halogens shows oxidation state, this is -1, right, and +1, right, +3 and +5. Suppose if we take NaF, NaCl. So here the oxidation state of chlorine is that is this one, that is -1. If we take +1, X is equal to 0, chlorine is -1. Now in some of the compound, that is other halogen shows oxidation. That's why other halogens shows oxidation state +1, +3, +5 and +7, right? Why it's so? There is a reason, that is due to presence of d orbital, right? This is due to presence of d orbital. So we see it. Other halogens means this is from after, except fluorine, this chlorine. So if we take the configuration of chlorine 17, and this is neon, and this is 3s2, 3p5. So it is represented in box model by Hund's rule. This one and this is 5. 1, 2, 3. This is 1, 2, 3, 4 and 5. This is 3p. This is 3s. This is ground state. Now there is a d orbital. 1, 2, 3, 4, 5. This is 3d is possible in other halogen. So there is one unpaired electron. So this one may gain electron, share electron, and it shows the oxidation state, that is that is -1 and the +1, right? Now, in excited state 1, energy is given, electron get excited. So from p orbital, 1, 2, 3, 4, and this one is here. This is 1, 2, 3, 4, 5. So how many there? Here n barabar 1. Here n barabar 3. So it will show the oxidation state 3, right? Again we take the another excited state. Now electron is again excited, ES2. So it will come here. This is again 1, 2. 1, 2, 3. And it comes here. This is 1, 2, 3, 4, 5. So this one. How many unpaired electrons are there? 3, 2, 5, 5. So this is the reason to show other oxidation state. Now ES3, what will happen? Then it is this oxided state. So this one. So chlorine shows maximum oxidation state. 1, 2, 3, 4, 5. So this is 1, 2, 3, 4, 5. So this one is +7. So this is the reason why other halogen, in addition to -1 and +1, shows oxidation state, that is the +5, right? And compounds that is with a known metal, if we consider as SnCl4, PbCl4, and this is SbF5, SbF5 or SbCl5, like this. So this is SnCl2 or BiCl5, and this is SnCl2, PbCl2, and this is BiCl3. So compounds in higher oxidation state, here oxidation state is +4, here is +4, and here is +5. Compound in higher oxidation state, that is the compounds of halogen with the elements which are not more electropositive, right? So it will share electron to complete its oxide, and it forms a covalent compound, and this is called the covalent. So as the oxidation state increases, its covalent character decreases. Means compound in higher oxidation state are covalent. As for example, this one. And as oxidation state decreases, its covalent character decreases. So this is character decreases. This is all about the oxidation state. Why it will show the, and HO, that is a fluorine. Fluorine always shows -1 because of its more electronegative nature. And this is HOF is the exception, because in this case the oxidation state is what? That is +1. HOF, if we consider HOF, this is +1, -2, oxygen is 1, and X. So X is equal to 2 minus this one. So this is equal to +1. So this is an exception case. Always it shows minus. Why other halogen shows the oxidation state? Somebody asked that is in addition to -1 and +1. NeF, if we take NaCl, where halogen is because the electropositive elements are there, and halogen have tendency to take up electron. That's why in NaCl these are formed. By gaining electron it completes its octet. So here the chlorine is in oxidation state, that is -1. Is it clear? Like this. So now with less electropositive elements, BF3, ELF3, like that, where the oxidation state is like the that is another. So we consider the why other halogens, so this one other oxidation state. Now the anomalous behavior here, if time permits. Now, if anomalous behavior, here I Consider the anomalous behavior. What is anomalous behavior? So oxidation state, anomalous behavior. Anomalous behavior. Behavior. What is the anomalous behavior? Means the dissimilarity in the properties of the first member with the rest member of the same family is called the anomalous behavior. मतलब इनको विषम गुण कहते हैं. मतलब पहले सदस्य से, पहले मेंबर से रेस्ट मेंबर के तुलना में गुणों में जो भिन्नता होती है, इसी को हम लोग एनोमलस बिहेवियर कहते हैं. जैसे फ्लोरीन पहला है, रेस्ट क्लोरीन है, तो फ्लोरीन का गुण डिफरेंट होगा और इसका गुण डिफरेंट होगा. जैसे आप देखेंगे फ्लोरीन -1 ऑक्सीडेशन स्टेट शो करता है इन कॉमन, लेकिन अदर हेलोजन जो है वह -1 के अतिरिक्त +3, +5 और +7 भी होता है. तो ये शो किया, पहला गुण हो गया. दूसरा होता है फ्लोरीन जो होता है उसमें डी ऑर्बिटल प्रेजेंट, फ्लोरीन का साइज छोटा होता है जबकि अदर एलिमेंट्स का क्या होता है, बड़ा होता है. तीसरा है फ्लोरीन में कोई डी ऑर्बिटल प्रेजेंट नहीं होते हैं, इसमें क्या होता है, डी ऑर्बिटल प्रेजेंट होते हैं. फ्लोरीन के कंपाउंड HF लिक्विड होते हैं जबकि HCl क्या होते हैं, गैसेस होते हैं. तो एनोमलस बिहेवियर का मतलब होता है डिससिमिलरिटीज, similarities in the properties of the first element with the rest members of the same family. Reason due to small size, another high electronegativity, another absence of d orbital. Supporting point, fluorine जैसे HF is जैसे फ्लोरीन, examples fluorine form HF liquid and HCl, this is gas. Fluorine shows oxidation state, that is -1, other shows +1, that is +3, +5, +7, like this. So these are the property and this is called the anomalous behavior. Now the another next property is explained in another class because it will take some time. So we consider the another one is oxidizing property and oxides later. Thank you.